guys, I'm April. So for today's video, pag-uusapan natin how peptide bonds are formed. As we have said from the previous episode, amino acid is the monomeric unit that joins together to form proteins. For example, this is our amino acids. So they combine or link together to form our protein, and we call this linkage peptide bonds. Before we study the polymerization process, we have to understand that amino acids have different forms inside our body and they are present in equilibria. This is the general structure for our amino acids, where we have the central carbon atom which can form 4 bonds. So we have the amino group, the hydrogen group, the carboxyl group, and the R group or our side chain. Since the amino group is slightly basic, it can readily protonate in an acidic environment. When we say protonate, it's accepting proton in the form of hydrogen. Here, our nitrogen accepted one hydrogen atom and in the process gained a positive formal charge. Why? So let's have a quick review on organic chemistry wherein nitrogen has 5 valence electrons. So kailangan mag-form siya ng 3 bonds to satisfy the octet. Wherein after forming the 3 bonds, di ba meron tayong 2, 4, 6, 7, 8. So, satisfied si octet. So, in the general structure, ganun yung itsura niya. Yung isa nakabond kay carbon, yung isa kay hydrogen, yung isa sa another hydrogen atom, leaving a lone pair. During protonation or hydrogenation, nag-accept tayo ng hydrogen. Nitrogen will be accepting one hydrogen atom. So, ang mangyayari itong electron na to, isi-share niya kay hydrogen forming a bond. By doing so, nawala ng isang electron si nitrogen, giving it a positive formal charge. Bakit? So, nitrogen has atomic number of 7, which means it has 7 protons and 7 electrons inside its atom. Meaning, yung positive and negative charge natin, nag-neutralize lang sa isa't isa, giving it a 0 charge. Pero after sharing that 1 electron to hydrogen, nawalan tayo ng isang electron. So now, instead of 7, meron na lang tayong 6 electrons. So 7 minus 6, meron na tayong positive formal charge, making nitrogen a positive cation. So this is the cationic form of our amino acid. On the other hand, we have the carboxyl group, which is slightly acidic, meaning it can readily deprotonate in a basic environment. So here, the carboxyl group will lose its hydrogen, giving oxygen a negative formal charge. Why? Again, let's have a quick review from organic chemistry. Oxygen has 6 valence electrons, so we have 1, 2, 3, 4, 5, and 6. So in order to satisfy the octet, it should form 2 bonds. So we have 1, 2, 3, 4, 5, 6, 7, 8. So, in the general structure of the amino acid, oxygen is nakabond kay carbon atom and kay hydrogen atom. After it deprotonates or lose the hydrogen atom, ang mangyayari, magbe-break yung bond na kay hydrogen. So, in the process, yung electron babalik kay oxygen. So, bakit kay oxygen pupunta yung electron at hindi kay hydrogen? Check the electronegativity in the periodic table. Since mas mataas yung electronegativity ni oxygen, mas malakas yung pull niya kay electron, kaya sa kanya mapupunta si electron. So after it deprotonates, magiging 7 na yung electron ni oxygen, wherein we have 1, 2, 3, 4, 5, 6, 7, wherein nakashare yung isa kay carbon, kaya we still satisfy the octet. Ngayon, bakit tayo may negative formal charge? So, oxygen has atomic number of 8, which means we have 8 protons and 8 electrons inside an atom. Kaya nanoneutralize yung charge natin. However, after accepting 1 electron, magiging 8 proton and 9 electrons na siya. So, ngayon, may sobra tayong isang electron, giving it a negative formal charge, making oxygen a negatively charged anion. So we have the cationic and the anionic form, and somewhere in between these two, we have the Zwitterrion. A Zwitterrion is a molecule with both positive and negative charge, and again, all of this form exists in our body in equilibria. The form in which the amino acid will take will depend on the pH of its environment. Again, the cation form is favored in acidic environment kasi parang acid-base neutralization lang to, in which the basic or the amino group will readily pick up hydrogen from the acid. On the other hand, the anionic form is favored in basic environment kasi yung acidic or the carboxyl group natin will readily deproteinate to give off hydrogen. Inside the body, the pH is regulated in most areas where it's fairly close to neutral pH. Highlight sa most areas kasi hindi lahat ng parts ng body natin ganon. For example, sa stomach. Yung stomach natin needs to be in acidic pH para makahelp sa digestion ng food na kinakain natin. In which, in neutral pH, the Zwitterrion form is dominant. So, the pH in which amino acid exists in neutral or the Zwitterrion form is called the isoelectric point, and iba-iba to for each amino acid. So, ngayon, pag-usapan na natin how amino acids combine together. So, polymerization happens when amino acids form peptide bonds with one another. For example, we have glycine and alanine. So, dito pa lang mapapansin nyo that both amino acids have the general structure of amino acid, wherein we have the amino group, hydrogen group, carboxyl group, and nag-iiba-iba lang sila based on the R group or the side chain. For glycine, we have a hydrogen atom. For alanine, we have a methyl group. Peptide formation is a dehydration or condensation reaction wherein from the word itself, dehydrate, we're removing water molecule. So, yung water molecule natin manggagaling from the hydroxyl group from the carboxyl group of glycine and hydrogen from the amino group of alanine. So, for example, magbe-break na yung bond na to. So, we have water molecule or H2O wherein we have dalawang hydrogen and isang oxygen. So, after losing the water molecule, both carbon and nitrogen is not stable. Kasi diba kailangan masatisfy natin si octet? So, both of them wants to be happy. So, they will come together and form a peptide bond. So, magpo-form sila ng bond. Wherein ngayon, si carbon, tingnan natin kung happy na siya. We have 2, 4, 6, 8. So, happy siya. So, si nitrogen naman is 2, 4, 6. And sabi natin, di ba, meron siyang lone pair. So, 7, 8, happy na rin siya. So, after these two amino acids combine together to form a peptide bond, this will result to an amide. So, an amide is formed when nitrogen is attached to a carbonyl group. Carbonyl group is when carbon is double bonded to oxygen. So, here, our nitrogen is bonded to the carbonyl group wherein carbon is double bonded to oxygen. Huwag kayong mako-confuse guys between carbonyl and carboxyl group. It's a combination of a carbonyl, so we have carbon double bonded to oxygen, and hydroxyl. Tinawag siyang hydroxyl because we have a hydrogen and oxygen atom. So hydroxyl plus carbonyl, carboxyl, carboxyl group, COOH. Going back, amide is the functional group that connects our amino acid during polymerization. Kung mapapansin nyo in any peptide, there will be an N-terminus which is the side that ends with the amino group and C-terminus which is the side that ends with the carboxyl group. Wherein each monomeric unit is called a residue. So, dapat we can still differentiate individual residue as well as locate the peptide bonds. So, here, ma-recognize natin yung residue by its R group or side chain. Since we have hydrogen lang, that's glycine, and here we have a methyl group, kaya alanine. So, paano natin malalaman nasan yung peptide bond? It's between carbon and nitrogen. Whenever we have two amino acids, just like our example, we call it a dipeptide. Di means two. If we have 3 to 10 amino acid residues, we call it oligopeptide because oligo means few. And then if we have more than 10 amino acid residues, we call it polypeptide. Poly means many. So a large polypeptide which contains 300 to 1,000 amino acid residues makes up our protein. So that's all for today's video. Sana may naitulong sa inyo. Thank you for watching. Bye!